Hi, geometry scholars. So I did something today that was a little weird. I recorded previously, but it didn't actually pick up sound. So I'm going to play this and try to do a voiceover. We'll see how that works. Okay, so we're on the second day of notes for Chapter 7, Lesson 3, in Big Ideas Geometry. And so you'll see, like I said, I'm going to try a voiceover. The directions here say state the theorem you can use to show that the quadrilateral is a parallelogram. So let's start. So you'll notice on A that you have two opposite sides marked, but you also have parallel, okay? And yesterday we had one of those theorems that said you can prove it's a parallelogram if opposite sides are like the same opposite sides if one pair is both parallel and congruent. They're both 30. They're both parallel. So all we have to really do is write down that theorem. This is what it looks like. If one pair of sides, opposite sides, that's right, are both parallel and congruent, then you have a parallelogram. Next one we're going to look at. Both opposite sides are congruent, and we have an opposite sides theorem. So all we have to do is write the theorem. Five and 5 are the same, 7 and 7 are the same. If opposite sides are congruent, then you get a parallelogram. I'm paraphrasing, it's not exact. And then we look at the last picture. Sides aren't labeled, but angles are. And we also have an opposite angle theorem. So if opposite angles are congruent, 65 and 65, and the 115 and 115, we just have to write if opposite angles are congruent, then you get parallelogram. Okay? And that's all you have to do. Just write the theorem. And that's how you show, that's some of the ways you can show that they're parallelogram. I have no idea what I'm saying here. Probably that this whole section is on how to show something's a parallelogram. So now we have a problem that has to do with the coordinate plane. And we want to show the quadrilateral is a parallelogram. So there's a number of different ways to do this. Okay? You can use slope to show that both opposite sides have the same slope. They're parallel. Or you can use the distance formula to show that AB is congruent to CD. Instead, what we're going to do is we're going to show that the diagonals bisect each other, because that's one of the theorems we went over yesterday. If you want to know where the diagonals would bisect each other, it's at their midpoint. So finding the slope and finding the distance, those are valid, but the easiest way, which we like easily, is to find the diagonals that bisect each other. So we'll be looking at AC, that's one diagonal. We'll also be looking at BD. Let's remember how we do this. We just find our midpoint. So we're going to go from A to C. And I'm just going to write AC, the line. We'll put a little mid there so we know we're looking for mid. So it's going to be the x's added together. So -3 plus 5. We'll divide that by 2. And then the y's added together, 3 plus 2. We'll divide that by 2. And so our midpoint is going to give us positive 2, right? That'll give us 2 divided by 2, which will give us 1. And then 5 divided by 2, which will be 2.5. So now to find the other diagonal, we go from B to D. So BD mid, again, we're going to add your x's together, 2 plus 0, and then divide by 2. The y's together, 5 plus 0, and divide by 2. So you end up with 1, comma, 2.5. So yay, the midpoints are the same. I hadn't highlighted that with some yellow. And I'm going to add like a little sentence to explain, because it's always a good habit for scholars. So because or since the midpoints of each diagonal are the same location or position, then the diagonals bisect each other. And that means that ABCD is a parallelogram. Okay, so there's the work, a little bit of an explanation, and that's all there is to it. There's not a lot of coordinate problems, but you do need to know what's what. So in the second part, there are some questions, right? I'm just checking to see that 1, 2.5 is the midpoint in the picture. So in the second part of the section, I made a chart for you. It's in your book, but I went ahead and added it into the notes. If you want to show that a quadrilateral is a parallelogram, this is like a little cheat sheet almost. If you want to show that both pairs of opposite sides are parallel, again, these are coordinate plane proofs, then parallel means slope. Okay, if it's the same slope, then the two lines are parallel. So that's what the picture looks like. If you want to prove it with a coordinate plane, that first one is going to be that you're going to write the slope. And you're going to show that they are the same, each opposite pair. Okay, so find the slope. Find slopes of opposite sides. Okay, if they are the same, so if they're equal, then you get a parallelogram. Then you get parallel. If you want to show that opposite sides are congruent, right? You want to show that picture. Now you're talking about length, so that's going to use the distance formula. It's based on the Pythagorean theorem, so you could also use the Pythagorean theorem. You can use the distance formula to find the side lengths. If they are congruent, then you get parallelogram. Okay, those are for the sides. Now, when we look at just angles, you see the third one, show that both pairs of opposite angles are congruent. You really can't do it. Okay, not with the coordinate plane. So just put a big old X in that, but just so you know, that's just not one of the things you can do. So we look at the next one. If you want to show a pair of opposite sides, just one pair are both congruent and parallel, well, then you have to use both. You have to do the slope and the distance formula on both segments. So use the slope for the parallel and the distance for the side length. But we have a theorem yesterday that said that if you have both of those, then you get a parallelogram. And last, just like we did right above, you can show that the diagonals bisect each other. And for that, you're going to use the midpoint. Okay, you're going to show but the midpoints are the same location for both diagonals. I hope this works a little better. This was weird. I rewatched it and just for some reason there was no, I think because I was listening last night with my headphones. Anyway, that's about it. That's 7.3. The rest of the period is going to be a work period. Definitely ask for help if you want it. Okay? And this will be the end of the video.